Have you ever wondered what happens when the sun, our very own star, throws a tantrum? A solar flare, in essence, is the sun's tantrum. It's when our star gets a bit too hot under the collar and releases a burst of energy. This energy, often equivalent to millions of hydrogen bombs, is expelled into space and can reach our planet, Earth. These solar flares are among the most dramatic and powerful events in our solar system. Imagine a burst of radiation so intense that it can disrupt radio communications here on Earth, nearly 93 million miles away. These flares, these tantrums of the sun, are not only visually stunning, but also carry a significant impact on our planet and its surrounding space environment. Interestingly, these solar flares are not random occurrences. They are closely tied to the sun's magnetic field. The sun, like Earth, has a magnetic field due to the movement of charged particles within its core. Occasionally, this magnetic field gets tangled, and when it realigns itself, it releases a tremendous amount of energy in the form of a solar flare. The study of solar flares has provided us with invaluable insights into the workings of the sun and its effects on our planet. But the more we learn, the more questions arise. For instance, why do some flares result in coronal mass ejections while others do not? What triggers the sudden release of energy? And how can we better predict these solar outbursts to safeguard our satellites and electrical grids? Solar flares are a testament to the sun's unpredictable nature, a constant reminder of our star's immense power and influence. The study of these celestial outbursts not only enhances our understanding of the sun, but also helps us prepare for space weather events that could have significant impacts on our technologically driven world. Dive in as we unravel the 10 surprising things we've learned from studying these celestial outbursts. Imagine 1 billion atomic bombs exploding at once. That's the power of a single solar flare. Solar flares, these spectacular eruptions on the sun's surface, are nothing short of celestial fireworks. But their energy, their power, is simply staggering. Picture this. The amount of energy released in a single flare is equivalent to more than 1 billion atomic bombs. Yes, you heard that right, more than 1 billion. It is an unfathomable level of power that we, as humans, can barely comprehend. And it's not just a show of brute force. This energy drives the sun's magnetic activity, fuels space storms, and even influences our planet's own magnetic field. It's an intricate dance of cosmic forces that shapes our solar system and beyond. The power of solar flares isn't just about the awe-inspiring spectacle of space weather. It's a testament to the immense dynamic energy that fuels our sun, our planet, and indeed, our very existence. And this overwhelming energy has some unexpected effects. Solar flares can give our planet a real shock, literally. Imagine the sun, an incandescent sphere of hot plasma suddenly releasing a burst of energy equivalent to millions of nuclear bombs. This is a solar flare, a spectacular phenomenon that can have surprising effects on our own home, Earth. One of the most fascinating impacts of these solar flares is on Earth's magnetosphere, the region around our planet dominated by its magnetic field. This field, generated by the swirling motion of molten iron within Earth's outer core, extends thousands of kilometers into space, forming a protective shield against the sun's harmful solar wind. When a solar flare occurs, it blasts a cloud of charged particles, or plasma, into space. If Earth is in the path of this plasma cloud, these particles collide with our magnetosphere, causing it to fluctuate and ripple. This disturbance is known as a magnetic storm. These storms are not just fascinating scientific phenomena, they are also responsible for one of nature's most spectacular light shows. When the solar particles collide with atoms and molecules in our atmosphere, they excite these particles, causing them to emit light. This is what creates the beautiful dancing lights of the auroras, also known as the northern and southern lights. But it's not just about the beauty. These magnetic storms can also have more practical implications. They can induce currents in long conductive structures like power lines, potentially causing blackouts and damaging electrical systems. So, while we marvel at the sight of an aurora, we must also remember that it's a visible reminder of the sun's powerful influence. An influence that not only creates a breathtaking spectacle, but also serves as a stark reminder of our vulnerability to the forces of the universe. But that's not all. These flares can also mess with our tech. Solar flares don't play well with our satellites. Picture this. A burst of radiation erupts from the sun, hurtling towards Earth at light speed. This isn't a scene from a science fiction movie, it's the reality of solar flares. Now imagine the satellites orbiting Earth, these silent sentinels of our digital age, right in the path of this solar onslaught. These flares, potent mixtures of X-rays and high-energy particles, can wreak havoc on our satellites. The intense radiation can damage sensitive electronic components, potentially leading to malfunctions or even complete failure. This isn't just an issue for space agencies and satellite operators, it affects all of us. Our world relies heavily on satellites for communication and navigation. Television broadcasts, phone calls, GPS navigation. All these could be disrupted by a single powerful solar flare. It's a reminder of our vulnerability in the face of nature's might. And yet, these violent eruptions play a crucial role in the sun's life. Solar flares are like the sun's heartbeat. This might sound like a poetic metaphor, but it's actually a pretty accurate scientific analogy. Solar flares are eruptions of intense high-energy radiation from the sun's surface, and they play a crucial role in the sun's magnetic activity cycle, much like the way a heartbeat is vital for the circulation of blood in our bodies. To understand this, let's take a brief journey into the heart of our star. The sun's magnetic activity cycle, also known as the solar cycle, is an 11-year cycle where the sun's magnetic field flips polarity. That means the sun's north and south magnetic poles switch places, then switch back roughly every 11 years. Now, where do the solar flares come into the picture? Well, they are the fiery punctuation marks of this solar narrative. Solar flares are most abundant when the sun's magnetic field lines are the most twisted, at the peak of the solar cycle. This period of maximum solar activity is known as solar maximum, and it's during this time that the sun's magnetic energy is converted into the kinetic energy of solar flares and coronal mass ejections. But it's not just about the flare-ups. The quiet periods of the solar cycle, known as the solar minimum, are just as important. These periods of reduced solar activity allow the sun's magnetic field to wind down and reset itself, preparing for the next cycle. Each solar cycle is unique, with varying intensities and durations. Some cycles have been relatively mild, while others have produced solar storms powerful enough to disrupt communication systems here on Earth. So, solar flares are not just spectacular space weather events. They are integral to the rhythm of our sun, the throbbing heartbeat of our solar system. They are the markers of time in a cosmic clock that has been ticking away for over 4.5 billion years. But how do we know all this? The answer lies in our relentless pursuit of knowledge. Solar flares are elusive, but not beyond our understanding. We've developed a myriad of methods and technologies to get a closer look at these spectacular solar phenomena. Scientists use space-based observatories, like NASA's Solar Dynamics Observatory, to capture high-resolution images of the sun in various wavelengths of light. This allows us to witness solar flares as they happen in real time. In addition to visual data, we also gather information using spectrometry, which deciphers the sun's light into its individual colors. This helps us understand the composition, temperature, density, and motion of solar flare material. Radio astronomy, too, is a vital tool in our arsenal. Solar flares often produce strong radio emissions that we can detect and analyze. This data helps us learn more about the flare's structure and the magnetic fields involved. We even use computer modeling to simulate and predict solar flare activity, enhancing our understanding of their complex mechanisms. And these studies have led us to some startling revelations. From their influence on Earth's climate to their role in creating cosmic rays, solar flares have some surprises up their sleeves. As we delve deeper into the study of solar flares, we continue to stumble upon some truly astonishing discoveries. These marvels of solar activity are not just spectacular to observe, but they also hold a wealth of information that is helping us reshape our understanding of the universe. One of the most unexpected discoveries has been the realization that solar flares are capable of accelerating particles to near light speed. This phenomenon, known as particle acceleration, is one of the most energetic events in the solar system. It results in the creation of cosmic rays, high-energy particles that hurtle through space at incredible speeds. Now, isn't that amazing? Another intriguing finding is the correlation between solar flare activity and Earth's climate. It may seem far-fetched, but it's true. The increased radiation from solar flares can cause changes in Earth's atmosphere, which in turn can influence our climate. This discovery has added a new dimension to our understanding of climate change, pointing to the sun's role in this complex issue. Next, we have the discovery of seismic solar flares, or sunquakes. Just as earthquakes cause ripples across our planet, these sunquakes send waves across the sun's surface. These waves provide valuable insights into the sun's internal structure, much like how seismic waves on Earth help us understand our planet's interior. Another surprising revelation has been the connection between solar flares and the sun's magnetic field. Solar flares occur when magnetic energy that has built up in the solar atmosphere is suddenly released. This process, called magnetic reconnection, can cause a dramatic increase in the sun's brightness, creating a flare. Perhaps one of the most intriguing findings has been the role of solar flares in the creation of solar wind. This stream of charged particles, continuously emitted by the sun, affects not just our planet, but the entire solar system. The understanding that solar flares contribute to this solar wind has given us a fresh perspective on the dynamics of our solar system. Finally, we have the discovery that solar flares can have a significant impact on human technology. The electromagnetic disruption caused by solar flares can affect satellite operations, power grids, and even our communication systems. The fact that these celestial events can have such a tangible impact on our daily lives is certainly surprising. These revelations not only enhance our understanding of the sun, but also of the universe itself. As we continue to study and learn from these remarkable solar phenomena, we are constantly reminded of the intricate and interconnected nature of the universe we inhabit. Each new discovery, no matter how surprising, brings us one step closer to unraveling the mysteries of the cosmos. Solar flares continue to captivate us with their unpredictable nature. From their sheer power to their profound effects on our planet, every aspect of these solar phenomena sparks our curiosity and deepens our understanding of the universe. We've journeyed through the enigma of solar flares, exploring their enigmatic nature and the immense energy they release. Comparable to billions of atomic bombs, these flares are a testament to the remarkable forces at play in our universe. We've seen how these flares interact with Earth's magnetosphere, creating the breathtaking spectacle of auroras, while also posing potential threats to our modern way of life. The charged particles from solar flares can disrupt our communication systems, and they have the power to damage satellites, affecting everything from GPS navigation to weather forecasting. We've delved into the solar cycle, a cycle that's been consistent for over 4 billion years. This cycle, marked by periods of increased and decreased solar activity, is intrinsically tied to the occurrence of solar flares. From studying solar flares, we've made some surprising discoveries. We've learned that these flares can accelerate particles to near light speed, and that they play a role in the sun's magnetic activity cycle. But as much as we've learned, there's still so much more to discover. The sun, with its fiery tantrums, continues to be a source of fascination. Each solar flare is a new opportunity for study, a chance to uncover more about the workings of our universe. We are just at the beginning of our journey. With every new insight, every surprising revelation, we are reminded of how much more there is to learn. We are reminded of the infinite mysteries that our universe holds. As we continue to gaze upon the fiery tantrums of the sun, who knows what other surprising secrets we may uncover? The fascination with solar flares, like the flares themselves, is far from fading. Instead, it continues to burn brightly, illuminating our quest for knowledge and understanding. As we continue to unravel the secrets of these fiery cosmic tantrums, we invite you to join us on this journey of discovery. If you've learned something new from this video, please give it a like and share your thoughts in the comments. We'd love to hear your opinions and questions about solar flares. Don't forget to subscribe and hit the bell icon to stay updated with more such content. The universe is a vast, fascinating place, and sharing this knowledge with your friends and family can spark interesting conversations and curiosity. Let's continue this cosmic journey together, one solar flare at a time.